Hello everyone, welcome back to my YouTube channel. As part of today's video, we are going to implement search system using conditional and branching workflow in LangGraph. This video is going to be a detailed video and will be covering multiple concepts we have in LangGraph. As part of our problem, we are going to ask a question to our LLM. Now, the LLM here will pause and think about the question. It will decide whether to call an external search system such as rack pipeline, database, context lookup to gather additional information, or our LLM itself is capable enough to answer this question. In this case, it will skip search step and directly answer the question. In second last step, our LLM will generate a final response with the help of provided optional context and question. Optional context is because we didn't go to search step to get the additional context, as our LLM is intelligent enough to understand the question. Now, in the last and step, LLM will return the final response to the end user. Now here, one thing to keep in mind is how all these steps in our system talking to each other and sharing information. This is done using something called as shared state, which is this one here. Think of the shared state as a data container that carries all the important information and it flows through the graph from start to finish. And every step or node can update it along the way. Here is how it works at each node. Node can read the data from the shared state to understand what is going on. It updates the state with new info, results, or decisions. This way, every step is aware of what happened before, can build on it, and helps produce a smooth, accurate final answer. For example, generate answer step here can read the context and question from shared state object, which got set by search node and decide search step. Let's see how we are going to implement search system technically using LangGraph Python library and OpenAI as an LLM. Suppose we ask a question to our OpenAI LLM and store same question in the shared state. This will help other node also to access this question. Now, with the help of decide underscore search function, our LLM will decide either to call search underscore node function or external underscore search function. If decide underscore search function plans to call search underscore node function, it will update the shared state need underscore search field value to yes. Now, need underscore search function will call external systems to get the response and update the shared state context field with the value here. Based on the root of our graph, generate underscore answer function will get called. Our LLM will read the context and the question from shared state and invoke agent to provide answer. Now, in the end state, it will return response to end user. Now, let's talk about second use case. If decide underscore search function plans to call generate underscore answer function, as our LLM is capable enough to answer the question by itself, it will update the shared state need underscore search value to no. It will completely skip the search underscore node function or step. Now, inside generate answer node, our LLM will read question from shared state and invoke agent to provide response. And in the final step, which is the AND step, it will return answer to end user. There are some must-know concepts. Let's discuss same one by one. As we are talking about LangGraph, which is nothing but a graph-based framework, and a graph is collection of nodes. We also call it as steps connected by edges. Decide search, external search, and generate answer are steps here. In LangGraph, a node acts like an agent that performs a specific responsibility in the workflow. Here, decide search node is decision agent, search node is research agent, and generate answer node is response agent. Now, edges are connections between steps in LangGraph. They decide where to go next after one step finishes, like arrows showing the path to follow. So whatever arrows we are seeing here, all are edges. Starting node of the graph gets called as entry point, and where the execution gets stopped called as exit point. Before we go for the implementation, let's first understand why our search design is powerful. The very first point is decision driven, not linear. Unlike traditional AI pipelines that follows a straight line from start to finish, this system thinks before it actually acts. It makes decisions at runtime, choosing the best next step instead of blindly following a fixed order. Now, the second point is retrieval only when needed, which is cost efficient. System fetches data only if the question actually needs it. This saves money, reduces API calls, and avoid unnecessary database searches, making the AI faster and cheaper to run. The third point is shared data across steps. All the steps in the workflow share the same memory, which we call state. This means decisions retrieve data and intermediate results are always available everywhere, just like how humans remember context while thinking. Now, the last and the final one is easy to extend with loops, retries, or human review. You can easily add advanced behaviors such as retrying failed steps, looping until a condition is met, or sending answers to the human for review. This makes the system production ready and scalable, not just a demo. This is all we have in terms of theory for this search implementation. Let's go to our Visual Studio and start the implementation. Now, before we start our implementation, we require one Python file. So let's create that. We can say graph.py. Now, we require some of the third-party libraries to be available in our local. The very first one is LangGraph, pip install LangGraph, and the second one is the LangChain underscore OpenAI. So these two libraries, the Python libraries we require in our local. Now to install these libraries, you can simply hit this particular command in your command prompt or in the ID's terminal. And similarly for pip install langchain underscore OpenAI, it will help you to install both the libraries. I'm already having these libraries available in my local. That's where you are seeing this requirement already satisfied. But once you have these libraries available in your local, you can go ahead and start your implementation. So now the very first thing we require here is the typing. So from typing, we require type dictionary and optional. So from typing, import type dictionary and then optional. Okay. Now the second one we require LangGraph dot graph, and from LangGraph dot graph we require state graph. Now from LangChain underscore OpenAI we require chat OpenAI. Now what these libraries are, how we are going to consume, I'm going to talk about each and everything one by one. Don't worry about that. Now once we have these libraries, and as we discussed earlier, the very first thing is we require the state for our application. So let's create that. We can say class agent state, and here you can simply say type dictionary. Okay. And now here you can define all the attribute. So question type string, then we require need search to decide. So it should be Boolean, yes or no. And then we require after this context. Okay. So context, it should be optional string. Okay. So optional string. Now, after this, we require answer, and that is also going to be a optional one. Great. Now, once we have the state, we require the OpenAI model. So for that, we are going to say LLM equal to chat OpenAI. So this particular chat OpenAI will take mainly two parameters. The very first one is model equals to GPT-4o mini. Okay. Now, after this, we require a API key. So for this API key, I have already created a detailed video. Go ahead and check out that video. It will help you to generate that API key. I am already having this API key. So I'm going to just copy paste this. So once I have the API key, we are good here. Now the third parameter we can declare is the temperature, okay, which can have the value from 0 to 1 depending on the requirement, but I don't feel that particular attribute we require here, so I'm just ignoring it. So let's proceed further. Now after this LLM, as discussed, we require three functions. So the very first function what we require is the decide underscore search. So let's say decide underscore search. And here it is going to take one parameter as state, which is of type agent state. Okay. And it will return the agent state. Great. Now I'm going to provide the doc string here. So let's say decide whether the question needs external data or search. Great. Now let's generate a prompt here. Prompt equals to format, and here you can say simply decide if this question needs external or up to date information. Okay. Answer only yes or no. Now here it comes our question after this. Question, here we are going to pass the state, and the bracket we are going to say question. Okay. Now as part of our response, so we are going to say response equal to LLM dot invoke and pass your prompt here. Okay. Now after passing this prompt, you can say dot content dot lower. Okay. Great. Now update the state value need search. need search equals to yes in response. Great. Now let's try to understand this particular code. Okay. So let me first return the state here. So return state. Great. Now here if you see, we are saying decide search. Okay. And in the decide search, we have given the agent state as we are planning to update the state as part of our all the functions. So now after getting the state, we got the question, okay, from the state because we are going to keep the question need search yes or no and the context and the answer within this state. So this state is already having this question. So we got the question from here and we pass this question as part of the prompt. So you can say decide if this question needs external search or not. So before we invoke our prompt, we are writing this particular statement and asking LLM, boss, if you are having this answer available with you, I don't think we require an external call to the API or the database. Okay, and you can go ahead and answer this question. So here it is doing the same, it is invoking. And if the response, if the LLM is having the response, then it is saying we don't require the search. If the prompt says yes, we require a call to the external database or the other system, then it will say yes. Then it will require a search in that case. Now, this is all about the site search. Now, let's proceed towards search underscore node. Now, in search underscore node, here also we are going to have one parameter, and this parameter is going to be there for all the methods or functions. And here we are returning the agent state after updating. So here also we are going to provide the doc string, and this doc string says simulated rag slash search tab. So here we are not creating an actual rag application. Okay, we are just asking this function to behave like a rag. Okay, and return the response. What response it will be returning? It will be returning this particular response here in the context. So context this. Okay, so in the context, it will say LangGraph is a framework built on LangChain. Okay, that allows you to build stateful multi-step AI workflows using Graph. Okay, let me keep in this doc string. Okay, so what we are saying here, we are saying LangGraph is a framework built on LangChain that allows you to build stateful multi-step AI workflow. Okay, great. Let me keep in the next line. Great. So here we have provided the context around the LangChain if we are asking for the LangChain. Now we are going to return this state and this state is going to have the context of LangChain. Great. Now the next part is generate answer, which will generate our answer and provide this answer in response to the LLM. And LLM will combine the intelligence and return the response to the user. Okay, so let's have this generate underscore response. So here also we can say generate underscore answer, and again it is going to have the state and agent state and returning the agent state only. Great. Now here also we are going to provide the doc string, which is going to say generate final answer using LLM. Great. Now here also we have to create a prompt. Prompt equals to format, and then we are going to have the string here. So we are going to say use the following context if available to answer the question. Okay. Now you remember we have kept the context here. Okay. Now we will get that context here. So we are going to say context colon, and here we are going to pass the state dot get the context, comma this. Okay. If we got the context, give me the context, else it will be empty. For the question, and question is also there as part of the state. So we can say here state square bracket and then question. Once we have the answer with us, we can simply say state and double quote answer equals to LLM dot invoke. And we are already having this prompt here. So we are going to use this prompt. Okay. And dot content. And here simply we are going to retain the updated state. Okay. So here we are going to generate the answer. If we have the context is fine. If not, we have the question with us and it will generate the answer for us. If it has the answer, it will return, and not, it will say, I don't have the answer for this particular query. Great. Now we have these functions. Okay. And these functions, what we discussed is nothing but kind of nodes. Okay. Now we have to create a graph. And after creating a graph, we have to attach it with the help of edges. Okay. So here we are going to use our state graph. Now, state graph creates a graph and tied to agent state. Also enforces state consistency across nodes. Here, we will attach our nodes with edges. Let's see the same. Graph equal to state graph. And here you just pass your agent state. Okay. Now, once you have this graph, you can say graph dot, okay, sorry, should be equal to. So graph dot add node. Okay. And the very first node we are going to add is decide underscore search. Okay. And here we are going to pass decide underscore search. Now, once we have this decide underscore search, after this, we are going to keep one more node, which is search. And it will be search underscore node. Now, the last node which got left is the generate answer. So here we are going to say generate answer. And here you are going to just say generate answer. So here we have created a graph and connected our nodes. Okay. And you just have to provide the entry node also, like from where you're going to enter. So graph dot set entry point. And the entry point is going to be the decide underscore search. Let me copy here. So it will start our flow from here. Great. Now, once we have these nodes with us, we are going to create routes. So define route, and here also you are going to provide the state and agent state, and it will help us to define the route of our application. So we are saying having if state require a search, need underscore search, then you should go where? You should go to the search node, which is this one here. Or you can directly go to the generate answer. Great. Let me copy paste it here. Now, once we have this resolved with us, we require conditional edges. Okay. So here we can say graph dot add conditional edges. Now here we require all the edges. So the very first one is decide underscore search. Now comma routes, whatever we have given there. And after this, we require two things. The very first thing is search, for which we are going to call this search. And give me a minute, colon. And the last one is generate underscore answer. And same we are going to keep here. Great. Now our conditional edges is also ready. Now let's add edge. So we can say here graph dot add edge. Okay. And the very first edge, the relation what we are creating is in between search and generate answer. So here you can say search, comma, generate answer. So we have created one edge in between search and the generate answer. And the last edge what we are going to create is from generate answer to the end, to just end the flow of our application. So here we can say graph dot add edge, and here you can say generate underscore answer. Okay. And here you can say and. Now to use this particular and, I have to include here from graph. So it will end our flow. Now after this, we have to compile our graph. So we can say graph dot compile. Okay. And keep this particular graph in apps variable. Okay. Now here you can simply say result equals to app dot invoke. And in this invoke, we do understand we wish to pass our question. We can say question, and here you can say what is LangChain. Okay. And our final answer is going to be the result. So here we are going to print the result, and we do understand our result. We have answer. Great. Now let's clear our console and first execute this. I forgot this bracket here. Sorry. Now let's first execute this application and later we will try to understand the flow. Now it's giving an error. This particular key doesn't exist, need underscore search. So here we have used and it's part of the state. So let's go up. So here, if you see, we have the typo. Let's correct this typo and we execute this code. So scroll up. Oh, it is need underscore search. Sorry, again. Let's re-execute this piece of code again. Yep, we got our output. So it is saying LangChain is a framework designed to facilitate this and this and this. Now, here we got our output we do understand, but let's keep some print statement here so that we can identify our function is getting called. So the very first one is inside decide search. Okay. Now after the search node, we require one inside the generate answer. Okay. Now let's create our console and re-execute this piece of code. Now you see it directly went to the generate search because it knew about the lang graph. Okay. And then it answered our question. Now here earlier we have searched for what is LangChain. Now let's ask something which our application or our LLM doesn't know. We can ask what are ABC company internal confidential documents. Let's see how it will behave. Now you see we got the output. Our LLM is not having any context around ABC company and its internal confidential documents. So in place of solely rely on the LLM, it will try to reach out to some other options. So it will go to the search node and look for the context around ABC and the confidential document. So it will go there first, and then again, after getting the context, it will try to generate answer. So now what it is saying here, I'm sorry, but I don't have an access to the specific internal documents. Here, our function search node got called because our LLM didn't have the answer. So this is how the LangGraph works in actual. It decides which particular node or steps to call to get the specific answer. Thank you very much for watching this video. Please like this video and hit subscribe button.